Hey students, in this video I'm going to go over the Unit 4 review. This is going to be a series of about 1, 2, 3, 4, 5, 6 videos. That way you can watch the video based on the topic. So this first video is going to be about number 1. Number 1 is asking you to write an equation of a quadratic function whose graph has x-intercepts of x equals 2 and x equals -4. So just imagine a quadratic either that looks like this or like this, and it has x-intercepts at 2 and -4. You don't know yet if it's open up or down. You just know that it has these x-intercepts. And then it has a y-intercept at y equals -16. So in my sketch, I think this one is the one that will have that. So let's just say you have a graph that looks like this, and your job is to create an equation for it. So you have different templates of quadratic equations. You have the standard form. Excuse me. You have the vertex form. And you have the intercept form. And you need to decide which one of these can help you create an equation based on the information given. So because they're intercepts, you're going to stick to starting with this template of intercept form. And you're going to substitute 3 different values here. You're going to substitute the A value, the P value, and the Q value. The P and Q are the intercepts. So therefore, you go back to the information you were given, or you look at this graph and you understand that you have these two, x equals 2 and x equals -4 as your P and Q. So when we put those values in there, we're still going to have the x and the minus. We're still going to have the x and the minus over here as well. But when we have double negative, we have talked about how that becomes positive. So that ends up what we have so far. We now need to see that we have to calculate that letter A to finalize our answer here. This A cannot be just randomly calculated by looking at it. We have to use the point that is given to you. So look at that y-intercept as a point in the form of x comma y. X is 0, y is -16. So we're going to replace the y value and the x values from that point. So y is -16, x is 0, and then this is what we have now. So we have an equation that is now asking you to solve for A. You're going to use PEMDAS to simplify this and solve for A. So we start by doing 0 minus 2, which is -2. 0 plus 4, that's +4. Then we multiply these two because these are together. And we have -8 as our simplified process here. This becomes -8. So you still have that A next to it. Once you're here and you want to just have A by itself, you need to understand that the A is being multiplied times this number. So to undo that, you need the inverse operation of dividing. Divide by -8, both sides. When you divide by -8, you isolate the A, and -16 divided by -8 is +2. This A is the A value that you're going to be plugging in right here. So to finalize our answer, we're going to write this template with these 3 values replaced. Y equals 2, parentheses, x minus the P value, which was 2, and then x minus, and then we put a -4, which made it +4, so we're going to have +4, and you're done. This is the equation. That is the answer to the information given. So one way to verify if that is correct is by graphing it in your calculator. And you can just type here the equation that you created. So I'm going to type 2x minus 2 times x plus 4. And this graph should have, according to your question, the x-intercepts of 2 and -4. So we're going to go to menu, trace, graph trace. And right now it's already showing you the y-intercept at 0, -16. And then if we go to the left side, all the way to the x-axis right there, it tells you 0, telling you that's the x-intercept at -4. And then if we go to the other side, we end up at 0 at +2. So this confirms that the equation that we created is the correct equation for this information.